Now we're going to take a look at example 2 from 6.3. It says solving graphically a system of two linear inequalities with continuous variables. It's going to be very similar to example 1, except we don't have to filter through a bunch of information. The inequalities have already been given to us. But there's one important thing that we have to sort of decipher here. So graph the solution set for the following system of inequalities. Choose two possible solutions from the set. So 3x plus 2y is greater than negative 6. Y is less than or equal to 3. Now remember back in the last example, we talked about step 1 was to assign variables. They've already done that for us here. They're x and y. Step 2 was to come up with the inequalities. They've already done that for us here as well. Step 3 was to determine the restrictions. Or was that step 2? Regardless, it doesn't say anything here about restrictions. If it doesn't say anything about restrictions, what we assume is that x is an element of the real number system and y is an element of the real number system. So there are no restrictions, so that's going to dictate what kind of shading we're going to do, what colors we're going to use on our graphs. So let's go ahead and graph these. We have our two inequalities ready to rock. So for the first one, we'll set it as an equality, as an equation, so that we can determine our boundary. So we have 3x plus 2y equals negative 6. So the easiest thing I think to do here is, we could go ahead and find the x-intercept. That's going to be a pretty easy thing to do. So we'll substitute y equals 0. And we'll say that 3x equals negative 6. We'll divide by 3 and get our x-intercept of negative 2. So that's going to be the point negative 2 and 0. The y-intercept, we're going to substitute x equals 0, so it's just going to look like 2y equals negative 6. Divide by 2 on both sides to get y equals negative 3. So that's the point 0 and negative 3. So here are the 2 points for our intercepts for that equation. So that's the two intercepts that we're going to use to graph it. We look at the other one. Y is less than or equal to 3. So what we can just call it is for the boundary is y equals 3. Hopefully you remember for y equals 3 that we're going to be looking at a horizontal line through y equals 3. So we have enough information to graph it. Let's do that. And pull out a graph here for us. Oh, that looks nice. So because of the fact here that we're looking at no restrictions on variables, hopefully you recall that no restrictions on variables means we're looking at green lines only. So I'm going to slide this over here, give myself a little bit more room so I can see what the original inequalities were. So the first one being 3x plus 2y is greater than negative 6. Now, there's no restrictions, but there's no equality possible. So that means our boundary line is going to be dashed green. So we can start at our x-intercept of negative 2. Use our y-intercept next of negative 3. And of course, like I said, it's inequality. Its equality is not possible. So it's going to be a dashed green boundary, just like that. That's the first one. The other one was y is less than or equal to 3. So because equality is possible, we're going to have a solid green line. And like I said, y equals 3 being the boundary, it's going to be a horizontal line through y equals 3. So we're going to make our solid green line right through y equals 3. So there are the two boundaries. The shading is what we have to think about next. So let's go ahead and take a look at the shading. For the first inequality, 3x plus 2y is greater than negative 6. We'll check out our origin. So we'll go 3x plus 2y should be greater than negative 6. We'll substitute 0 and 0 for x and y at the origin. It's right there. So 3 times 0 plus 2 times 0 should be greater than negative 6. 0 plus 0 is 0. We should get 0 is greater than negative 6. Oh, that's not true. So where are we going to have to shade? We're going to have to shade below the dashed green line. Again, I'm not going to shade it just now just because I can't make it lighter or darker. But just keep in mind the dashed green line we're going to shade below. Now for the other one, pretty easy to determine the shading. It just says y is less than or equal to 3. It tells us where to shade. We have to shade everything that's less than or equal to 3. So for that horizontal line, we just have to shade everywhere below that line. So since we've shaded below the dashed line and below the solid line, below both of them, this region right over here Sorry, let me backtrack just for a second here. We'll go back to this. 0 is greater than -6. For some reason, I forgot about the negative. So, of course, yeah, 0 is greater than -6. So, in fact, for the dashed green line, we're going to be shading above it because 0, 0 does work. We are going to be shading above it, but we are still going to be shading below the dashed green line. So now it's the region below the solid green line and above the dashed green line. So that's going to be this region right in here. This region has been shaded twice. Because it's shaded twice, this is our solution region. Of course, if it was class, you guys would be yelling at me saying, oh, you made a mistake, that's not right. Don't have you guys to watch out for me. Now we're going to go back to the question. It says choose two possible solutions from the set. So let's do that. Anything that we want to do here realistically, because we're looking at real numbers, so we don't have to have whole numbers if we don't want. Clearly, using whole numbers or integers is going to be a lot easier, but as long as we pick any 2 points from the solution region. So in the book, they chose 1 point as being 0 and -3. I'll use the blue marker to illustrate that point. 0 and -3 right there. That's in the solution region. We can use that. The other one that they used is 2 and -3. Now you can use any set of points in that solution region. Anything you want at all, and they are going to satisfy it. So now the next thing we can do is we can take a look at what this would look like on a graph, on a graphing calculator. So we'll turn on our graphing calculator, put it right into y equals. So remember that when you're doing this, you have to isolate y. We'll go ahead and do that. For the first one, pretty easy. Or sorry, for the second one, pretty easy. Y is less than or equal to 3. Y is already isolated, so we can graph that in a moment here. For the second one, 3x plus 2y being greater than -6. We'll subtract 3x from both sides to get 2y is greater than -3x minus 6. We'll divide by 2 to get y is greater than -3 over 2x minus 3. So this is what we're going to punch into the graphing calculator. So let's do that right now. We'll go with the first one of y is less than or equal to 3. So we'll just go 3 right here, but we're going to go over and do our less than or equal to, or just even the less than. Okay, so now we're going to go to the next one. And the next one's going to be greater than, so we'll put the shading above, just like that. And we'll type in the -3 over 2x minus 3. Should be good to go here now. We should be good to graph. We'll hit it. See what happens. There's that horizontal line. That's the original horizontal line. The other one's going to be oblique. And look at that double dose of shading in that same region, just like we had on our smartboard. So that is going to be it for example 2.